Hello everybody, welcome to part B of chapter 9.2. Today we're going to focus on the other half of the chapter where we talk about sums of arithmetic sequences. We're going to learn how to find the partial sum of an arithmetic sequence, and we're going to go through the formula of how to find that. And we're also going to use these sums in real life examples. So, let's just jump right in with an example. Again, the formula though, so we're going to start by saying the sum of an finite arithmetic sequence and all the word finite means here is that there would be a first term and a last term that we're trying to find the sum of. And we can do that if we use the formula S sub n equals n over 2 outside a sub 1 plus a sub n. So the first term plus the last term times whatever the number of the last term is over 2. And we will go through that in the first example. So let's say we were given the question, find the sum. And say we're given a whole sequence written out. So say we're given 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. Just by looking at this, we can start to find some information that we need. We can tell right away that this is arithmetic. Because it has that common difference of just plus 2 every time. And we can see that the last term is 19 and the first term is 1. So I'm going to label those a sub 1, and the last term is a sub 10, which happens to be 19. And what we're going to do is we're going to use that info. Let me see if I can maybe zoom in a little bit here. Do I have a button for that? Maybe like this. There we go. Okay. There, that's a little bit better. Okay. And what I can do now is I can use that last term, 19, and the fact that it's the 10th term, and I can use the first term, 1, and I can sort of plug everything into my formula. So, I'm interested in finding the sum of up to the 10th term, so I'm filling in a 10 for n. And again, I'm filling in a 10 for n, so 10 over 2, outside a sub 1, which is 1, plus a sub n, which is 19. The 10th term, the thing I'm stopping at, is 19. When I start to simplify here, I know 10 over 2 is 5. And I know 1 plus 19 is 20, and I know 5 times 20 is 100, and that's my answer. Let's do another example. Let's say we were asked to find the sum of the integers from 1 to 100, and from 1 to capital N. So for the 1 to 100 case, I'm just going to say that right here, 1 to 100, what I would do is I would label this as a sub 1, right, my first term, a sub 1 is 1. And then 100, well, that would actually take me 100 terms to get there, right? A sub 100 is 100. Every number from 1 to 100, well, that would be the 100th term in there. So, when I throw everything into my formula, I'm finding S sub 100. 100 is my n value, so I put that over 2. My a sub 1 value is 1. And the n value, and incidentally also the term value at 100, is 100. And so 100 over 2 gets me 50, and I'm multiplying 50 by 101. When I do that, I get 5,050, and that's my answer. A lot of this, as you can kind of start to see here, is just identifying what's your first and what's your last term. So for the case from 1 to n, again, just like the last case, a sub 1 is 1. However, we don't really have an ending term value. We just have an a sub n. The a sub n we're going to substitute in with the big letter N, the capital N. So we can still kind of use our formula. We can say S sub big N, right, that's where we're stopping, is N, big N, over 2, outside our first term 1, plus big N. And that's really it. I mean, you could substitute, distribute here and get N over 2 plus N squared over 2, but it's really not that necessary. This is our answer. Okay. So let's find a partial sum when we're not given as much information. Let's find a partial sum. So finding a partial sum. This is going to be a little bit different because, like I said, we're given a little bit less information. So, say we were asked to find the 150th partial sum of the arithmetic sequence and here we have it. It's 5, 16, 27, 38, 49, ... Okay. And we don't have the 150th term, but we can find it if we create a formula to find it. Remember that we have a formula we can use to find any term in a sequence, and it's this. A sub n equals n times the difference plus c. Right? We did go over that in yesterday's video. And we're going to create this formula by first finding each piece. In order to find so we have this formula we can use to find any term, and we need that. We need to do, in order to find any sum, in order to do the formula to find the sum, we need to have a first term, which we already have, which is 5. But we also need to have the 150th term. We need to have the term that we're ending at. And in order to find that, we can use this formula. So let's start finding all the pieces that we need for this formula. First, to find the difference, we can just do that by looking at our sequence. To go from 5 to 16, from 16 to 27, from 27 to 38, the difference that's happening there is plus 11. Plus 11 every time, right? Plus 11. And so we say the difference is 11. Again, just by looking at it, I can see the first term is 5, so a sub 1 equals 5, which means I can take this and I can find my c value. My c value is a sub 1 minus the difference, so 5 minus 11, that's going to be negative 6. Now I have everything I need to create my formula. A sub n equals the difference, 11 times n, minus 6, right? Plus c, and c is negative 6, so I have minus 6. Now I'm going to use this formula to find the 150th term. To find a sub 150, I plug in 150 for n. So I'm going to have 11 times 150 minus 6, which means that I get 1,644. That is my 150th term. Now remember, we're not done. We're going to take that information and we're going to plug it into our formula for finding the sum. The sum is n over 2 outside a sub 1 plus a sub n. Right, where we begin, where we end, and the value of where we're ending. So, to find the sum of the 150th term, s sub 150, We plug in 150 for n. We plug in our first term, and in this case it was 5. And we add that to the 150th term, which we just found to be 1,644. When I do some math, I get 75 over 1,649. And when I multiply that together, I get 123,675 as my answer. And that's it. You just kind of have to work backwards and use your knowledge of arithmetic formulas to find missing terms first. Next, we're going to do a word problem before I let you go. All right, I have written this out ahead of time, so you can take a second, pause the video, and just write out the question. And you don't have to draw this picture. If it does help you, go for it. But if not, that's okay. I understand. I just drew it out so I can kind of help explain to you what's going on. All right, so let's read it. An auditorium has 20 rows of seats. There are 20 seats in the first row, 21 seats in the second row, 22 seats in the third row, and so on and so forth. How many seats are there in all 20 rows? So this picture does kind of describe what's happening. We know that in the first, second, and third there are this many rows, this many seats, 20, 21, 22 seats. And we don't know how many seats are in the rest. But what we can do here is we can use our knowledge of arithmetic sequences to find the sum. The first thing we need to know is how many seats are there in the 20th row. Because if we're going to find the sum, remember, to find sums, we need to have a beginning and we need to have an end. Right now, we don't have an end. We don't know how many seats are in this last row, so we can't do the sum yet. However, we can find the number of seats in the 20th row if we create a formula and then plug 20 in for our end value. So, to begin creating that formula, we're going to need to know some things. We're going to need to know what our a sub 1 is. We're going to need to know what our difference is. And we're going to need to know what our c value is. To find a sub 1, we can just kind of look at this picture. Well, the first row had 20 seats. So the a sub 1 in the context of this problem is 20. To find the difference, we can look at the change in seats for each row. We went from 20 to 21, 21 to 22, and we can tell that the difference, the common difference between these terms, is plus 1. Now to find the c value, I need to do my a sub 1 minus my difference, 20 minus 1, which gets me 19. Now I can use all of this info to create my formula. A sub n equals my difference times n, or just n, plus 19. That's my formula. Now, I'm going to use this formula to find however many seats are in this 20th row, right? I don't know, and I need to know that if I'm going to find the sum. So, I'm going to plug in 20 for n. I'm going to say number of seats in 20th row. Well, that's what I'm finding right now, and I'm going to find that by plugging in the 20 for the n here. So I'm going to say a sub 20 equals 20 plus 19, 39. There are 39 seats in the 20th row. And now that I know that, now that I know a sub 20, I can definitely use my sum of an arithmetic sequence formula. So remember again that is s sub n equals n over 2 outside a sub 1 plus a sub n. So what we're doing right now is we're finding the sum of all 20 rows. So s sub 20. Again, n is 20, so I'm filling that in. In the first row, a sub 1, there were 20 seats. In the last row, what we just found, a sub 20, there were 39 seats. And now I do some math. 20 over 2 is 10. Inside parentheses, I have 59. 10 times 59, remember I just add a 0 at the end, I get 590. And so I can conclude that the total number of seats in all 20 rows is 590. Alright, that's all I have to show you. Thanks for watching. We'll see you in class tomorrow.